Hello and welcome to the lecture on Lighthouse Project at Ranchi. My name is Shailesh Agrawal, Executive Director of BMTPC, and I'm going to educate you all through this presentation about the field level implementation of innovative construction system being used in Lighthouse Project, including design basis, material, manufacturing, few structural drawings. The outline of my presentation is as follows, starting from Global Housing Technology Challenge India and Lighthouse Project. The technology being used in the project will be discussed. Ministry of Housing and Urban Affairs, Government of India organized Global Housing Technology Challenge India, in which one of the component was Construction Technology India Expo Exposition, which was inaugurated by Honorable Prime Minister of India on 2nd of March 2019. Through this CTI 2019, Ministry of Housing and Urban Affairs could evaluate, assess and shortlist 54 proven demonstrable technologies which can help build maximum number of houses in minimum time and minimum cost. These 54 new construction systems have been divided into these 6 broad categories, namely precast concrete construction system 3D, volumetric precast concrete construction system 2D planar, light gauge and steel structure system, precast sandwich panel system, monolithic concrete construction, and stay-in-place formwork system. Today, we are going to discuss precast concrete construction system 3D volumetric, which is the construction system being used at Ranchi. Before getting into the technology, let me briefly tell you about the 6 lighthouse projects which are currently being implemented in different parts of the country. They are in Chennai, Rajkot, Indore, Ranchi, Agartala, and Lucknow. As you can see, the houses being constructed are more than 100 in all the places, and number of floors vary from 6 to 14. At Ranchi, the structure is 9-story. Just have a look at the layout of the project at Ranchi. There are 7 blocks, as you can see in this drawing: 1, 2, 3, 4, 5, 6, 7, and all these blocks are in the configuration of ground story plus 8-story. So it's 9-story. There are green spaces up to 20%. And as you can see in this typical floor plan, there are 16 dwelling units in each floor, which are connected through a corridor of 1.3 meter wide. This is a typical dwelling unit plan. It's a 3D view, which explains you that there are 2 rooms. One is a bedroom and a living room. Then there is a kitchen, then separate bath and WC. The norms for this EWS house conforms to the sizes of the rooms and service areas given in National Building Code of India 2016. Along with the NBC norms, the other features which have been included in the project are as follows: green rating as per GRIHA, use of renewable resources in terms of rainwater harvesting and solar lighting, solid waste management, sewage treatment plant with recycling of water, and firefighting system have also been included as per NBC 2016. Let me just explain you first in general what is the technology, and then we will go into the specifics of this technology. What you see on the left hand side is the prevalent construction systems, and world over there are 2 kind of building systems which are being practiced. One is load-bearing structure, which you see here, and load-bearing structures normally brick masonry or any other masonry walls are laid brick by brick with mortar, and over that cast in situ RCC slab or sloped roofs are erected. The other system, which is much popular of late, is cast in situ RCC framed structure, where on a foundation RCC frame comprising of columns, cast in situ columns and cast in situ beams. They are cast, and then slab is cast in situ and infill is done with any masonry. So these two methods, as you all know, are time consuming. They are not resource efficient, and over the time, it has been found they are not even sustainable and not environment friendly. It is high time that we replace these systems by systems which can help build faster without sacrificing structure and functional performance. One such system which was evaluated, assessed, and shortlisted during Global Housing Technology Challenge India is precast concrete construction 3D volumetric. What you can see from this slide, that instead of doing all the things at the site, if we make the entire module in the factory and lift it at the site and put one over the other or side by side to erect the multi-story tower or to erect a building, then you can get away with a lot of things like air pollution, noise pollution, waste generation, and the project will become sustainable. So we are trying to replace cast in situ construction by 3D volumetric construction. Why it is called 3D volumetric? Because instead of making these walls and these columns in the factory, we are making the entire unit in the factory. There are two variants. You can do the entire thing in the factory and then transport it to the site, or otherwise you can set up a casting yard, small casting yard at the site, depending upon your project requirement, and cast these modules. So it's a modern method of building by which concrete structural modules, it can be a room, it can be a kitchen, it can be a toilet, it can be a bathroom or a staircase, or it can be the entire dwelling unit, which can be, cast in under controlled condition, either in the factory or in the casting yard, and then can be transported to the site and assembled, jointed together to give you a building or a multi-story tower. Let me just explain you the manufacturing, transportation, and installation. What typically is being done? You first of all, you have the mold. Mold, depending upon the project and depending upon the size of your dwelling units, depending upon the size of your rooms. First of all, it is decided that what kind of modules need to be made or need to be cast, and depending upon that, you first design the modules. These modules primarily are made of steel with high repetitions. So this is the kind of module, and then based on those sizes of the rooms or modules, you do the structural design and try to arrive at the optimum reinforcement which is required, because primarily it is a RCC construction. So as you can see here, you are putting a base, and over that base you put the reinforcement cage, and then you put this module, and then you do the concreting. So this yellow thing which you see here is a hopper through which concreting is being done. So first reinforcement cage is being lowered, and then the steel mold is being put, and then you do the concreting. Once you do the concreting, this concrete is of high quality and high performance. This mold is demolded. So what you get is you get this module. And once you get this module, you lift it and put it on the trailers, specially made trailers, and then you can transport them to the site. While transporting these modules, you have to take utmost care, and there are standard operating procedures through which you will have to transport them to the site, so that the damage during transportation and during handling is minimized. So again, you can see here the module being brought to the site on the trailer, and then they are put on the already laid foundation. So the foundation here is conventional, and once you come to the plinth level, you leave some dowel bars, and there are already made dowels and holes in the module. So both of them are connected at the foundation level, and then these modules are aligned and erected like this. Once you make the one floor, then what you do is you can put the reinforcement and screed, and then make another floor. This way you can the house very, you can construct the house very quickly, and having minimum number of joints and having minimum number of repetitions. Structural elements, if I talk about, because the entire thing is made volumetric in 3D modules. So the walling element, the floor, your roof, all are cast together. So the entire box is the structural element here. So basically, this 3D box acts as a structural system which helps in transferring the load of the structure to the soil-proof foundation. As you can see, for manufacturing it, first you require the steel mold, which is again customized, and it, depending upon the project requirements. Sometimes these modules, 3D modules, are also known as pod elements. Then you have this high strength steel, which is again coming from the structural design, that steel is placed in these 3D molds. Whatever services need to be put, if you are doing a kitchen pod or you are doing a toilet pod, you need to fix pre-planned electrical and plumbing lines, and once you have fixed all services, then you have to pour the concrete. There are strict quality checks which are taken before pouring the concrete, and then they are also transported to the site under strict supervision and erected in the same fashion. Construction sequence normally follows the following sequence. First of all, you need to make the foundation, which will be as per the soil strata and as per the geotechnical investigations and bearing capacity. And once you do the foundation, after that, you have to bring those structural modules, which concurrently you can manufacture in the factory or in the casting yard. Once you get those structural modules or the pod elements at the site, you can put them on the already laid foundation after aligning them and after joining them together through dowel bars and through already laid anchors and other things. Okay, gable end walls are positioned to terminate the sides of the building. So end of the room are known as gable walls. So sometimes you can make it without gable end walls. It again depends on the project and your requirement. So you can have an open-ended module, and then later to have monolithic action, you can put the entire end wall. That wall again is being made in the casting yard. As again, if these spans are high, then you can use pre-stressed slabs. It can be hollow core slab as well. But if you have a small size span, then you can get away with the pre-stressing, and you can have a solid slab as well. Rebar mesh is also being placed for structural screed. Once you put the module over the foundation, and then in order to have another floor over this, so normally screed is nothing but a concrete of less thickness. It is around 75 to 100 mm thick, with nominal reinforcement, which is a rebar mesh, is put over the already laid module so as to connect it with the floors which will come over that structure. Let me just briefly show you the entire sequence through a video. So mesh is being put on the mold, and then you can see electrical boxes and conduits are being put, and now already made concrete is being poured here. This is self-compacting concrete, so you don't require any compaction. And after some time, you demold it. Demold means remove the module, then casting is covered, and then it is steam cured for 8 to 10 days. Once it is cured and gained strength, then through a gantry girder and crane, you lift the module. And right now that lifting of module is taking place. So once it is once it is lifted, then it is taken to other part of the casting yard, where you can put, if as per your requirement, you can put the finishing items in this. Suppose you are making a bath or a toilet pot, so you can put the seats. If you are doing the plumbing, you can do the plumbing. Here this waterproofing and tile application is shown. Then you can put as well as the ventilators, doors, windows, then the WC wash basin, and now this pod is ready. And after final finishing, this pod can be loaded on the truck and can be transported to the site. So this is how it is being laid, and we need to design these anchor bolts also for lifting it and putting it on the trailer and then transporting it to the site. So that is also designed, these anchor bolts. As you can see here, the surface is again cleaned, and high strength concrete is poured if you want to make the slabs or walls. So this is how the walls, again, depending upon your project, you may have the entire 2-3 modules, or you have open-ended module, and then slabs are cast separately, and they are being here. The casting of slab is being shown to you, and again, this is being steam cured for early strength, and then these slabs are being demolded and transported to the construction site. So suppose you have to make the roof, then you can just put it over the already. And these are those dowel bars which I was talking about. So through these dowel, the two floors are being connected. Now you can see here how this is the foundation, and this is the plain beam where you have a double bar. Then over that you are putting a bath and WC, and then you are putting other modules. Then these gable end walls are these external walls which we are putting, which are being put to connect all the modules together. Over that, these slabs are being put. You can see, and after putting that precast slab, you will put the reinforcement mesh so that everything is connected together, and then concrete screeding will be done. After concrete screeding, you can put the another floor, and that is how the whole thing can be repeated for next floor. So that's how block by block, it is like a Lego block. You make these blocks in factory and then put one block over the other, carefully, joining them together through these dowel bars which are already inserted. So this is how it, this is the finished building. Now, let me just give you, because there are a lot of concerns being raised about the reinforcement being used here, because these being thin sections, and how modules are being connected side to side, and one over other. So this is a typical structural details of a typical module. So it has 4 walls, so you need to provide a vertical and horizontal reinforcement. And if it is less than 100 mm, then you can have 1 layer reinforcement. If it is more than 100, then you can have 2 layer of reinforcement. So this is a typical module of size 3.5 meter by 6.8 meter, and these are the reinforcement requirement. And to have better seismic resistance, you need to have continuity of reinforcement at the corners, whether it is a L joint or it is a T joint. The reinforcement is to be continued from one corner to other, by placing additional bars and stirrups. So this is how the detailing is done, and there you have to put the reinforcement on both the sides, and this is the typical reinforcement which is shown here. So this is a typical module reinforcement, and now connection and joints. As you can see here, there are several connections when you join different modules together. So what you see here, these are the external vertical connections, these are the internal vertical connections, and these are the horizontal connection. Horizontal connection means we have to connect this module with this module, and how these modules are being connected, that I'll try to show you. Then internally, these are the vertical connection when you are putting one module over other, how they are being connected, and these are the external connection. So if you look at the external vertical connections, so normally what is being done, you put a double bar. So this module and the other module which is coming over this, these two are connected through a plate. This plate is already fixed in the module, and then then a double bar from this and double bar from the modules, they both are welded with this plate. So you can see here, this is a steel plate, This is a steel plate which is already cast with the module at the time of casting, and then yeah, this base plate is welded through these double bars. These are the long bars which are 20 dia bars, and these bars are welded with this thing, and to have it integrated with the slab, you have a double bar which is extending from slab, and that is also cast, that is also welded with this two bars. So this way you will get the integral monolithic action at the joint. So this is, these are two modules, and this is the slab which is being cast. So you have double bars in all the three, and they all are welded with this plate, which is shown here. Now let me also show you the internal wall connections. So you have this internal walls. So these internal walls, how they are connected again, you create a, you put up the base plate, and then over base plate, if you have some packing material may also be put, and then the bars which are, or there are holes which are created during the casting. It is called sleeve, and in which you insert reinforcement 16 mm, 20 mm, depending upon the size, and these bars are welded with these plates. So this is one module, this is another module, and these are the modules. So there can be a four-way connection, it can be a two-way connection. So depending upon depending upon the connection you have. And if you look at the plan, this is how it looks like. So this is one plate, this is another plate, and this is how these bars are being welded with these plates, so as to have a monolithic connection. Now let me also show you horizontal connection. If you have to connect them side by side, this is how it is being connected. So here what you do, you put a steel angle. So this is a precast modular slab, and this is again a precast slab, and this is your module which is coming. So you are putting angle, and through this angle you are welding this bar which is shown here, and then the opening which is being created is filled with non-shrink cementitious grout. So if you see the section, it is the section. So what you have here is the angle, and then through this double bar, this is welded on both the sides to give you monolithic connection. Now, suppose in this project we are having a corridor as well. So when you have a corridor is normally cast in situ, and the idea is to cast it in situ is so that all these modules can be connected monolithically with this corridor. So normally it's a good practice to have a corridor in between, and through this corridor you can ensure connection of all the modules together. And how it is being cast, you can see here. So you are putting a reinforcement bar, and there is a rivet here, and with this rivet, this is welded, and then the bar is put inside. Now there is another connection, how to connect the module with the staircase landing. So this is a precast module, and then this is the landing of your staircase. This is how it is being connected. As you can see, you have to use non-shrink cementitious grout to cover the bolt. So what you do is you put anchor. There is a bolt sleeve here. Bolt sleeve is created during at the time of casting, and then that sleeve is slightly more than the diameter of your bolt, and then you put the bolt, and that bolt is then grouted with non-shrink grout, and then it is connected through nut and bolt with the landing of your staircase. So this is another connection. If it is a mid landing, then how do you connect it? And there are two modules. So this is how it is being connected here. There are several advantages of this system. Let me also tell you, this is for the first time that this technology is being used in India at such a large scale. And as you can see, entire construction activities, including finishing, are being done in the factory under controlled conditions. So 90% of building work, including finishing, is done in the factory. So there will be significant reduction in construction and occupancy time. There will be significant reduction in the material wastage. Almost there is no wastage of material, and at the site you will get a clean environment. And once you do entire operations in the factory, you bring resource optimization. You have improved much better quality, precision, and finish. Also, when we are using a concrete here under controlled condition in this project, they are using the GGBFS, which is ground granulated blast furnace slag, or any other waste material which is a byproduct. Fly ash is a byproduct of thermal power plant, and this GGBS is the byproduct of your steel plant. So any waste material can also be added as a pozzolanic material, replacing your part of cement. Up to 30% cement can be replaced by these waste material, resulting into conservation of natural resources, and you also get improved workability and durability. The surfaces are so smooth that you can, these are ready to use modules. So and they are sometimes called plug and play modules as well. So what you can do is they are so smooth and finished because they are coming from the factory. So they can be immediately used. You don't require plastering of the surface. And plug and play home means once you finish the erection, you connect it with the electrical and plumbing services and water services, and you can start using these houses immediately. And since these modules are cast together in the factory, so all walls, the connections, all joints are minimized, because there is continuation of reinforcement, and casting is being done in one pour. So almost there are no joints, and so there are no chances of leakages, which help in low maintenance, and thereby reducing the overall maintenance cost of your building. Minimum material wastage, and as you know, at the site you will have clean construction site and dust-free environment. Also, you can control when you do the construction at site. Sometimes there is no control on water uses, because workability of concrete vis-a-vis water. If we see, and normally water, we keep on adding water to improve the workability of concrete, and that way we make concrete permeable and porous. Okay, so when the concreting is being done in the controlled conditions, you can optimize the quantity of water, thereby reducing the use of water. And as I showed you, all you require is a mold, steel mold, and these molds are of steel, and that steel is recyclable, and these molds can have repetitions up to 100, 200, or more than 200. So the use of shuttering, scaffolding is entirely eliminated. All you require is heavy machinery for lifting and transporting. And these houses can be made in any weather conditions, and you can organize it better at the site. The essential requirements which you require, because right now this is a new technology, so we don't have production facilities in different parts of India. So wherever you have a project, there you have to create a casting yard, and for that casting yard you need to give additional space to the agency, so that the casting of different modules can be done. And if the factory is located far away, then you have to transport in long trailers those things, so sometimes it may not be economical. So setting up of casting yard at the site is must. That is the requirement. Secondly, you require a lead time, because you have to first set up a casting yard, and then you can start the construction work. Also, another essential requirement is because these are modules which are made in big sizes, so accordingly you have to have approach road to the site and movement of trailers and trains. Because this is a specialized technology being executed by specialized people, and there are, when you put modules side by side or one over other, you have to connect them properly. You have to weld the bars with the base plates, so you require a skilled workforce, and it has to be done under strict supervision. As in any other technology, here also you have to pre-plan plumbing and electrical services, and once that is done, it is difficult to alter the plumbing and electrical services at a later stage after occupancy. That was all about this project, because unfortunately this project is just started a few days back. Right now geotechnical investigation is being done. After that there will be laying of foundation, and then in the meantime casting yard is also being set up, and once we have modules being cast in the factory, we will share with you all those photographs, and we will also show you the actual site photographs and try to explain you the construction sequence in detail. In the meantime, you can also visit GHTC-India.gov.in. That is the website where you can see the live status of this project, along with the other lighthouse projects which are being executed in different parts of the country. You can contact us at the following address, which is given here. You can write to me on sk@vmtpc.org.